Yeah, I can hear myself. My name is Petr Ferschmann. I'm founder or ex-founder of FlexiBee accounting software. Currently, I'm working on two projects. One is called Dativery and second Phoenix. And Phoenix is a company that is doing backend or cloud consultation, and that's the reason I'm here. I organize backendist meetings in Prague, and I also make Cafe Mlejnek TV. That's a video podcast for developers. I would be glad if you join or subscribe to our YouTube channel or our web, Cafe Mlejnek TV. Before we start, I would like to remind you the classical architecture, three-layer architecture. We have client or browser in this case, application server, this is the server, and this is SQL database. And one way how, this is the classical architecture, and one of the things you have to solve is how to scale it. Usually when your project grows, so you start to do something like that. You add more application servers, and you add some kind of load balancer or something like that that puts all the requests between all the servers. So we increase the performance. So do you see what is the problem of this architecture? It's of course a high availability. This is not high available, and it can fail. And we usually lie to ourselves, or we are kidding ourselves that it will not fail. Today, everybody is using more and more applications, and we need higher reliability. Because in the past we were using 1-2 applications. Today everybody of us is using 10, maybe more application. And if one of them fails, it's a problem for us because we can't work. And the probability is bigger because we are using more applications. Customers or users usually don't have backup solutions. It happened to me more than one time that I was in a city and my phone broke, and I didn't have a map and I didn't know where to go, so I was lost in the city, and because I didn't have backup solution, and that's common today. And customers can choose the application that's not failing, because if you fail too often, they will change the application. So usually we end in something like this. This is the architecture that is used in FlexiBee. FlexiBee is an accounting software. So we tried to remove all single point of failures. So we have multiple load balancers, we have multiple application servers, we have multiple stores, these are SQL stores, with slaves, read-only replicas, and this is the architecture. There are more things like configuration that we have NoSQL database in FlexiBee because we need to know where customers' data are located because there are multiple storages like this. So this is quite complex, and it gets more and more complex, and it costs more and more money to manage it. In the past, we were doing that. We developed the software and put it to the administrator of operations, and they were running the software. But today, the problem is that they couldn't fix all the problems inside because they were not developers, and the developers were not taking care of the application or the operations, so they were not taking care of that, and they were not solving it. But I remember one time when we were on the mountain, and one of my colleagues had to make calls to Prague to be sure that it's working, because there was some kind of problem with connection pooling with SQL database, and they had to find out why it was leaking the connections. And that's something that operations can't fix themselves. So today we are moving more and more to DevOps, developer operations. So the developers are running the software and they are making it work. So, DevOps. The problem of this architecture is, or this kind of direction is that developers don't like to manage the servers. They want to develop. Okay, that's that's the only things they have to care of. So we have to do another problem is that the developers are getting more and more expensive. In the past, there were big differences, for example, between Pilsen and Prague, and today it's almost the same, and it's getting almost the same in whole Europe. For example, in Palestine, you pay $3,000 to developers, and it's nearly the same like in Pilsen or Prague. So the developers are more and more expensive, and they don't like to make the operations. So, how to decrease costs of servers and operations? Okay, so I said that. So, what is the best solution? The first solution is to ignore the problem of high availability. Because, for example, in AWS, if you are using AWS, it's not hard to completely ignore the high availability. For example, RDS. Who of you have experience with AWS? And who haven't? Have no experience? Yeah. So, for example, in AWS, there are managed services like database. It's called RDS, Relation Database. And the good things about that is that they completely manage everything. The hardware, the operating system, the database. And it's, the database is stored on the EBS, that's a network storage, elastic block service it's called. And the good thing is that EBS by itself, it has, I think, 6 replicas or something like that. So if the disk fails, it's automatically replaced by another one. And the RDS is a classical virtual server that is managed by you. And if the hardware fails, for you it means like just rebooting the system. Because if the hardware fails, they will start again another server that will have the same IP address, everything, but it's different hardware. And that means that if 1 minute failure is not a problem for you, don't care about high availability and just ignore it, because it will start in 1 minute. That's the same with virtual servers in AWS, because if the server fails, it will start again. EBS has high availability inside, you don't care about it. RDS you can have multi-availability zones, multi-AZ. In the case of AWS, it means that AWS have many server rooms or housings, and every, or they call it region. We have, the closest is in Frankfurt, it will be in London, it's in Ireland, and there are more, I think 10 or something like that there are. And every, this region, it has multiple availability zones. These are completely separated server rooms that don't share anything. They have multiple connections, they have separate electricity, backup solution for electricity, and so on. And the multi-AZ means that the database has read-only replica in another server room in the same city. But it means that it costs double the price. So the first solution for high availability is to ignore it. For example, who of you is doing high availability software or running it? Only 2 of you. You don't care about how it is run. Okay, and in your company, you don't. I don't mean that you exactly in your company, because it's to you. How are you doing it? Yeah, okay, but your company is running the high availability software, or not? No? Do you have any customers? Really? Yeah. Sorry? For example, in case of FlexiB, the ignoration of the problem meant that we were not testing properly the failover of the database, for example. We were not testing if the if the master database fails, the failover to the slave. The slave becomes master and we are running. So we were not testing that. That's the ignoration of the problem. But if the failure for you is problem and you try to take care of everything, it costs a lot of money. It's very, very expensive to be sure that you never fail. For example, you have to have multiple servers, multiple rooms or locations of the servers, and it costs a lot of money. So the second solution I would like to tell you about is to use platform as a service. It means that you just provide the software and the platform is running the software for you. So you don't have to take care about all the technical details and they are doing it for you. So what does it mean for me, platform as a service? The first is virtual servers, but I'm not sure if we can call it platform. It's infrastructure, but sometimes it's hard to separate it. So virtual servers. Function as a service, Lambda, I will be talking about it later. Store, blobs. Do you know what's the difference between a blob storage and blob storage? The difference is that blob storage is that you put the file in the storage and it takes care of everything, but you can't modify the file. You can't modify the file, you can only store or replace it. Because you have less options, they can take better, better care of the high availability. For example, S3 has, I think, six replicas. If you store something in S3, they have 6 replicas, and they say that they have about, I think, 10 nines, 99% 0.99999 of the failure. And that's because it's not generic file system, it's blob store. S3 is very, very good example of a platform. CDN is a network, content delivery network, but it's great for more cases. For example, in case of AWS, CDN can make a high availability for you. You don't have to take care of it, and they can help you to lower the latency of your application. I have another presentation. I will be talking about today about latency, and latency is the biggest problem today, and CDN is helping to make it less issue. For example, if you have server and you are using HTTP or HTTPS, it's faster if the CDN location is closer to you, because if the client connects directly to your server, it means that the HTTPC, SSL handshake, or HTTP request, and so on, DNS takes the latency of your connection. If you are using CDN, it only takes latency to the CDN edge, and from this point there is an usually already connected connection to this server. So it's faster to use CDN, even in the case if you are not caching anything, just connection. Do you understand that? Because the handshake is local, not remote to, for example, Ireland or something like that. Manage database, either SQL or NoSQL, and today NoSQL starts to be better and better. Load balancer, AI, but that's completely different topic. So, The first things that PaaS makes is that it converts but most of the problems to money. For example, if you have to solve something, you can start with the things that PaaS is offering, and you can count how much it costs, and then you can say, okay, it's too expensive for us, and we have to choose different way. So everything changes to money, and money it's easy because you can get money easily. It's hard to get good people to work on it, but if you can just pay, it's easier. Yeah. So what we were doing was that this is a use case of one of our customers that was running their own servers, and they were considering to move to AWS or to platform as a server. It's a real case of an application, but I can't tell which one is it. This company had one 8 CPU server with 64 gigabytes of RAM, and the server costed 100,000 crowns for 4 years. And they are paying housing 2,000 every month. There were another payment for management of the server. It was about 10,000 crowns. This page or customer has 65,000 visits every month, and it means 8 million requests every month. They transfer 8 terabytes. That's quite a lot. And their database have 8 gigabytes, and their static content 800 gigabytes. And the peak is about 300 requests per second. This is what they were providing, and this is their cost. If we count it, it's about 15,000 crowns every month for the management of the server. Problem is that it's not a high availability solution, and the backups were on another server. It's not counted here, but it was server that was used on more customers. So we are not counting it, and this is how we transfer it to the AWS. We transferred, we were using CDN for the static contents like images, and we were using managed MySQL database, RDS, and it was written in PHP, so we converted PHP to Lambda and were running it in this way. So how much it costed? It costed, RDS cost $100, and together it costed $155. And the S3 storage was quite cheap, but what was very expensive is the traffic. CloudFront or AWS is very expensive for traffic. You pay a lot of money for traffic, and if you, for example, use CDN 77, it could cost half of that, $300 in this case. And for this customer, the best solution was to use their currently existing server and use it like a proxy, caching proxy from the S3. The thing is that the server is already there, and they were not paying for transfers to Czech Republic. So if we use this way, it would cost $800. That's nearly twice as much as they were paying to rent currently. But they don't have to take care of backups, they don't have to take care of peaks, and everything was working, flawlessly without anything you have to do. The only way how to improve this is to use the RDS in multi-AZ. That means that there is a slave replica that is always ready to switch to, and it would cost $100 more. So this is a real example of transferring to AWS. It costs more, definitely it costs more, but you don't have to take care of this service. You just run it or use it and pay. That's it. In case of AWS, the only question that you ask is how much you pay. If you want to compare companies, just ask how much they pay. That's all. So, any questions to this comparison? In the AWS, the storage is quite cheap, $20 for this case, and the running is quite cheap. The most expensive is this RDS and traffic. So, let's go on. So, the first things is how to compare AWS and classical servers. This is what I call server days or something like that, or server months. This means the red line is the traffic or the demand we need. This is how much servers we need, and the green is how much servers we have. If the demand grows, we have to add more servers. You understand that? So, but this is bad because in this case we have this number of server months. But if we want to be sure about high availability, we have to have more servers, because if one of the servers fails, we have to have enough performance to be able to run the service. In this case, if the one server fails, we don't have enough capacity to run the service. So you have to use this one. And if you use something that can grow with your demands, like AWS or something like that, it's this amount of server months, because you can change the needs. Yeah, the server months are nearly half, but the cost is higher. If you want to use AWS for virtual servers, it's expensive. So if you are comparing the costs, it takes a lot of, the first computation is very, very high. But if you count how can you save money? Like, if you buy this rate array, it costs a lot of money, but you just use a very few gigabytes of it. So it's hard to compare. So, and the main thing I would like to talk about today is a function as a service. Lambda in the case of AWS, and in case of every provider is running it. It has something like that. So what is it? Function as a service. It's nothing new. We could always run services on the provider's servers, but when we are using functions, it means that we lose some of the flexibility and we change it for some advantages. One of them is that we run only one function instead of the whole application. Every function is running only one request. Classical application server like Tomcat or something like that is running a lot of requests in parallel. Function as a service is handling only one request at once. It means that the requests can be run on many servers, so they are parallel requests, but they are completely separated. After the request is handled, the function is destroyed. So it means stateless. And the management of how many functions there should be prepared, where they are running, is completely out of your control. And AWS, in this case, is taking care of that. So you just don't have to take care of that. So we can compare virtual server, container, and function. In the case of virtual server, you have to take care of operating system management. You have local storage. You can storage data on the virtual server. In the case of function, you can't. And runtime is usually long. Uptime of a server is usually maybe years. I have heard that average mean time between AWS failure of a server is 1 year. in my experience, it's not 1 year, it's more. But sometimes AWS can reboot your server. So the runtime is long. If you want to do autoscaling, do you know what is autoscaling? Autoscaling is that if you need more capacity, it will grow what you are using. So you can manage all the services, and it also means that for example, in night it will grow, it will shrink. So autoscaling is manual or slow. When you need new capacity, it can take between 10 minutes to 1 hour. In case of FlexiB, we are using virtual servers, and we were managing them with Puppet, and it means that when we needed new server, it took about 1.5 hour to install all the necessary software, to upgrade operating system from the image, and to replicate some data to be able to grow the capacity. So reaction time is usually in minutes. If you need more capacity, it takes minutes. Memory is per instance. It means that when you are handling multiple requests, you are sharing the memory together. So if you are generating PDF, for example, you can need a lot of memory, and it could mean that you are taking the memory from other requests, and they will fail because you are taking the memory from them. So sometimes one customer can make impact on another customer because they are using the same system. So if something fails, it takes down the whole instance and all the requests that are currently handled. So in case of container, I don't take care of host management, operating system management, and I'm just using it. The runtime is still long, but autoscaling is usually faster. For example, in case of Docker, it takes much shorter time to add another server. So autoscaling is tens of seconds. Memory is still per instance, and error take down the whole instance of the Docker. And in the case of function and service, you don't take care about operating system, you don't take care about local storage. It's stateless. Usually the runtime is very short. For example, Lambda has a limit for 5 minutes. It can't run longer than 5 minutes. If you need autoscaling, it's not a problem. When you need to grow the capacity, it takes seconds to have hundreds of servers that will take care of it. Every memory is shared it's not shared, it's per request. So one customer will not take down another customer. And if something fails, it's only one request. So, Amazon is one of the providers, Google Cloud Platform, I think that is called Functions. Bluemix, I think that is called OpenWhisk, Microsoft Azure, I'm not sure what it's named there. Heroku, the question is if it's function as a service. So, what is it AWS Lambda or function? This is it. This is Node.js. The function is a code. It can have megabytes of code, and there is a request, it's an event, there is some kind of context, then you can read some information, and you create a response, in this case it's HTTP response, and just return. That's all. That's all Lambda. It's very easy, and you don't take care of anything, just write this code. In our case, we are using the serverless framework, I will be talking about it later. So, this is Lambda. What the difference is that in case of Lambda, you pay for megabyte seconds and not, you pay per request and by megabyte seconds. For example, for your function, you say how much memory, maximum memory it will need. For example, you say it needs 1 gigabyte of memory, and you will pay for gigabyte seconds. The limit is maximum is 5 minutes. You can say how much is the limit for the running, and the maximum is 5 minutes. And one of the greatest things is that it costs the same amount if you compute something 60 seconds or if you compute it in 60 parallel servers 1 second. It's the same amount of money. Yeah. So, and it's stateless. So, this is the price. You pay 20 cents per million of invocations, and you pay this amount of money for 1 second, 1 gigabyte. So, for example, if we want to run surveys for 60 seconds, for 24 hours, and we need 1 gigabyte of memory, it costs this.
You pay for idle time?
No.
No, if you, I don't mean like real idle time. I mean when you request data from database or...
Yeah, you pay for, when you are waiting for network, you are paying for it. Yeah. So, I will talk about it later. So, when you are using AWS, there is a free tier. It's something that you get for free, and usually it will end after 1 year. But in case of Lambda, it will never end. So you get 400,000 gigabyte seconds for free and 1 million of invocation. I've heard of one company that was using Lambdas for generating previews of images. They were eShop, and they needed to, they uploaded image to S3, and they needed to generate previews in many resolutions. And after half a year, they converted about I think 5 million of images, and it cost them nothing. Because of the free tier. It has disadvantages, the free tier, because when you are using it, you start to think that it's for free, everything, because there is the beginning is for free, but after some time you will start to pay, and it's not cheap, but it's cheaper than running your own servers or running virtual servers on AWS, because when you don't need anything, you don't pay for anything. So you pay just for the request. And the great thing is that if you have requests during the day, you don't need to pay for during the night. So just for the request. That's great. So what kind of events you can invoke the Lambdas? Usually it's HTTP requests, classical API gateway. You can handle requests. You can call the Lambdas directly, and you can listen to platform events. 2 years ago, I was on a hackathon, and they had a lot of money. I think it was 200,000 crowns on credit for AWS, and I wanted to create Lambdas that will take all of them. They will consume it. So I created Lambda that invoked 10 Lambdas, and they invoked 10 Lambdas, and I made something in parallel. And it was very quick, and the capacity was huge. But I wasn't able to consume the money because of the free tier. And I really tried. And when I went to the organizers and I said to them that I want to eat all the money, they say, okay, but there are more people than you. And I said, okay, I will eat them anyway. And I tried that, and I was running all the requests. We were doing service that was calling Twitter and searching every second something. And I started to run it. I ran it for 10 minutes, and I was happy that I'm consuming a lot of money. So, and then I got an idea: is their credit card or mine? So I looked, and it was mine. So we quickly switched it to there, but I had to pay what was there before the switch, and it was $5. I was afraid how much it would be, but only $5 because of the free tier. So this is the event. These are the events that Lambda will can be invoked directly through the API. That's the usual usage. You create Lambda, handles some API request, and it's done. You just listen for the request and you handle them. Because Lambda is usually the basic web interface is that you write the code on the web page. That's not very software developer friendly. So we are using Serverless framework, and this framework allows you to easily deploy the Lambdas from your Git repository, and you just use it. It's really good. It's using CloudFormation. That's declarative configuration of AWS. I can talk about AWS later, more about that. And their support, the serverless framework support AWS, they support OpenWhisk, and I think Azure now, they support too. So.
May I have a question?
Yes.
There was a context where you use that function. What's that function?
Yeah, that's the environment where this is run. Usually it can be the role, that's something AWS is using for permissions. I can talk about later. So it's there. There can be authorizer. That's when you authorize the user, the user of your application. You can get the information about the user in this context, and you also get the variables of the Lambda. The Lambda can have some variables that's so it's easy to configure it. For example, you can have the same Lambda in many stages like development, production, and it can have different variables. So that's the context. So serverless is good. So comparison of EC2. EC is Elastic Cloud Computing. It means virtual server on AWS versus Lambda. If we have small app that handles 10,000 requests per day, every request needs 556 megabytes of memory and runs for 200 milliseconds. It means this amount of invocations, it means this amount of gigabyte seconds, and it means this cost. So if you have service that have this amount of requests, it will cost you this amount of money. The great idea is that you don't have to take care if all those requests are during 1 hour or if they are during the whole month. You just pay the same amount of money. You don't care if you need hundreds of servers to run it or just one small server because it's not in parallel. The AWS takes care of that. Another case, Chrome, you need to run every 1 hour, you need 1 gigabyte of memory and it takes 2 minutes. So it's 790 requests per month. This amount of gigabyte seconds and this costs the money. It's quite cheap. The great thing is that if you are making Chrome, you have to take care if it's high available. If it was run, where it was run, because if you have a bigger deployment, it takes some time to manage it, to be sure that the Chrome is always run and it's run only once. And in this case, you just say, I want to run this Lambda every 1 hour, and it will be taken care of that. You just don't need to worry. There is another comparison. If you need 100 milliseconds, 100 megabyte of memory, and you want to compare it with the EC2, it means this amount of requests, and that means that you have to take care of 80 requests per second, and it will cost the same amount of money as the virtual server. Of course, if you have 80 requests per second, you usually can't have only one server because it's quite a lot of requests. But in case of Lambda, you just don't care. This is comparison in case of If you need 1 second, 1 gigabyte, it means 2 per seconds. Is it? Do you understand that? Questions? Don't worry to ask. So, yeah. Yeah, languages. Yeah, sorry, I missed it. You can use Node.js, you can use Java, you can use C# or .NET, the one framework. You can use Python, and you can use nearly everything. That's one of the things. Yeah, I have it here. It's okay. So, what is AWS Lambda and how is it implemented? In AWS, it's something that is run in container. It's like in Docker. Yeah, so you create a zip of everything you created, you upload it to S3, and they deploy it from S3. So if you make request, they will choose server, unpack the zip, and start your application in the container. So the container is complete separation, and you can run binary code in there. So you can use PHP, but it has to be, for example, Node.js module. If you convert PHP to Node.js module, you can run it there. It's Linux. I don't know. I think it's AWS Linux. They have special distribution, but it's classical Docker, or it's not Docker, classical container that is run. So you can use anything you want. Between the container is ready for some time. So if you make a request, they will start it, and when the request is finished, the container gets freezed. It means that it will stop getting CPU, and you can use anything you want, but it's freeze. And when there comes another request, it will unfreeze the container, handle the request, and freeze again. For example, if you have a background thread that is taking care of a connection pool, it will take care of that only during the handling of the requests, because otherwise it's freeze. But you can use background threads. Because it's container, you can store data locally, but you never know if you will wake up again ever. Because if there is no request for 10 minutes, they will kill the container. And when another request comes, they will again unpack it and start. So the first request takes some time. It depends on the size of the zip. So the smaller the better. It's faster. And the server, it takes care of the number of servers that are ready to handle your request. So it's stateless, but you can store. For example, we are caching data locally. In the case of Dativery, we are using Node.js, and we cache data locally, and so it's faster because you don't have to call it again. The static initialization is kept, so you can store data, for example, in static variables because it's there, still there. One of the interesting things is how much performance you get. The server is divided by 100 to 28 megabytes of memory. So, and the CPU too. So if you need more power, you need to provide more memory. So the double the memory, the double the CPU. For example, if you have something that lasts 1 second, so if you provide it double the memory, it will take half the time, and you pay the same amount. Even if you don't need all the memory, you can use less, but you will get more power, more performance.
Does it feel linear?
Yes, I think to the maximum of the memory of the server. I think it's hundreds of gigabytes of the server. I don't know.
I actually need the CPU time, because then it would make sense to only use like 10 gigabyte chunks of Lambda functions or something like that.
Yeah, I'm not sure. You can use more CPU, more threads, so you can run it in parallel. I'm not sure if you will get more than one CPU. I'm not sure, but it scales to some gigabytes of memory. I never tried it. How much it will take care. I just know that if I provide more memory, it gets faster. Of course, if you are waiting on a network, it will not help because you are still waiting. Stateless, yeah, static initialization, warming. Yeah, if it's problem for you, the initialization is sometimes good to invoke the Lambda every 10 minutes to make sure that at least one is warmed, is prepared. But you know, if the number of requests in parallel grows, they will add more servers, and it will take some time to. There is a limit on the number of deployed lambdas, because you know, if you invoke lambda, that invokes lambda, and that invokes lambda, you could easily during few seconds consume all the capacity they provide, and of course lose all your money and maybe all the money of your ancestors. So there is a limit, and then how much parallel you can get. But if you ask AWS, they can increase it. It's for protection, for your protection. So, for example, if you are preparing some kind of advertisements and you expect that thousands of people or millions will get to your service at once, you can ask the